Retrieval code can be slow or wrong before an embedding model runs. Sometimes the problem is the collection you chose. This lesson uses Python data structures for small ranking and filtering tasks. The point is to choose containers that make lookup, ordering, counting, and deduplication obvious. The core containers are lists, tuples, sets, dictionaries, and counter. A list keeps order. A tuple works well for a fixed pair or record. A set removes duplicates and supports membership checks. A dictionary gives named lookup. Counter turns repeated items into counts you can rank. Open the file retrieval_collections.py and find where raw documents become candidate records. Notice which collection is used at each step. The code should not use a list for everything. If the task is membership, use a set. If the task is lookup by ID, use a dictionary. If the task is scoring repeated terms, use counter. The best choice is usually the one that makes the next line of code simple. If you keep asking whether something was already seen, that is a set. If you keep fetching a record by ID, that is a dictionary. Run the demo and look at the ranked output. Do not stop at the final order. Follow the path from raw text to tokens to counts to selected candidates. Retrieval bugs are often quiet. The code returns something, but it may be the wrong something, and the cause can be hard to see later. The test should cover ordering, deduplication, and lookup behavior. Add a small failure case too, such as an empty query or duplicate document IDs. These tests are cheap. They catch mistakes that look minor until a downstream prompt receives repeated context or misses the document it needed. When the output surprises you, inspect the intermediate containers. Print the token list, the deduplicated IDs, and the score dictionary. Those checkpoints usually reveal whether the ranking logic or the data shape is wrong. Keep the data structure choice boring and visible. Python has useful collection tools, but dense one-liners can hide the shape of the data. Prefer the structure that makes the next operation obvious. A readable loop with a dictionary is often better than a compressed expression nobody wants to debug. The goal is not to memorize every collection method. The goal is to recognize the operation you are doing, then choose the collection that makes that operation cheap and readable. An interviewer might ask, how would you choose data structures for a simple retrieval pipeline? A strong answer is, I use lists when order matters, sets for deduplication and membership, dictionaries for lookup by stable keys, and counter for frequency-based scoring. Then, I test the behavior that affects ranking, because retrieval errors can be silent.